Good morning, good afternoon, and good evening, everyone. I'm Alessandra Colecchia, the Head for Science Technology Policy at OECD. Welcome to all from the team organizing this event. We have over 1,300 registered participants from about 80 countries today. I hope you enjoyed the high-level panel, which ran just before. But today, I'd like really to introduce, and I'm honored to introduce to you our keynote, Professor Sheila Jasanoff, who is Professor of Science and Technology Studies at the Harvard Kennedy School. And Sheila, in her work, she explores the role of science and technology in the law, politics, and policy of modern democracies. And Professor Jasanoff is also a prolific writer, and her books include The Fifth Branch, Science at the Bar, Designs of Nature, and the Ethics of Invention, and Can Science Make Sense of Life? So Sheila will talk about new directions of science and emerging technology for inclusive transitions. So without further ado, Sheila, the floor is yours for your presentation.
Thank you, Alessandra, for that introduction, and thank you above all for inviting me to participate in this really important meeting. Thanks also to David Winikoff, who has been a friend and colleague for so long. I'm happy to be here because of the time constraints. Let me immediately start sharing my screen and going through the brief remarks I've prepared for this morning. So science and emerging technology for inclusive transition, new directions. We could obviously be here for a very long time discussing these issues, but let me hit on a few high notes. So if one looks at just the news of the day during this pandemic, one sees immediately why this topic is of such urgent interest. On the one hand, we have the miracles of science, the vaccines that were rolled out in record time and that have proved their relative efficacy in relation to the coronavirus. And all over the news, you can find references to the miraculous speed and efficiency with which scientists were able to capitalize on prior discoveries and to be able to produce a level of protection that nobody had imagined would be available in that kind of time. But on the other hand, side by side, we have worries about equity, about the inadequate supply in poorer countries. So if it is a miracle, it's not a miracle for all. And this, I think, is part of the challenge for OECD and for all international organizations looking at the frontiers of technological development. So I think we have to take a step backward in order to take steps forward. So we have to understand something about the theories, the models by which we think about science and technology diffusing into the world, because somewhere in that process, the inequalities come in and the problems of inclusion present themselves. So this is the very most basic model of how research gets into innovation and then eventually gets out into society. It's known as the linear model. More or less anybody who's had the ABCs of science and technology policy knows that this is a vast oversimplification. And yet this simplification still lodges in some of the most high policy places in the world. So I think it's worth dwelling for a couple of minutes on the embedding of the linear model in people's thinking before we begin to complicate the picture and come back to a new directions point. So from the beginning of science and technology policy in the United States, people have talked about how there's a social contract for technological innovation. It's assumed in that model that society is one thing and that all that the government needs to do is pump money into the R&D side of the linear model, and eventually the innovations will result and they will be available to all of society. One can call this almost a set of central dogmas. US science and technology policy immediately after World War II embraced the idea that the more science there is, the more innovation there will be. Innovation will lead ineluctably to social welfare. National governments therefore have a duty to foster science and technology innovation, and there are even numbers for how much of GDP ought to be put into innovation in order to produce a productive pipeline. Science and technology, for their part, should be left more or less free to set their innovation agendas, and one has policy tools with which to fix the problems in that social contract. The idea that science and technology lead to progress is also so profoundly embedded that emerging technologies are seen as good in themselves. So technology is almost seen as synonymous with progress. It improves our condition and our lives. After all, technologies are instrumental. They're developed for purposes. Technology is also thought to be driven by science and ingenuity and resources, and hence it's not considered to be social in any deep-going sense. Technology is thought by many people to shape society, an idea that has come to be called technological determinism. I'll come back to that point in a few minutes. And then technology's impacts on society, when they're negative, are usually called unintended. So the beneficial consequences are intended. The negative impacts are usually dismissed as unintended consequences. So that is the central dogma, if you will, of the linear model. And some of our most notable inventions and innovations of the last half to full century seem to bear out this idea. So information technologies that have transformed all of our lives, that make it possible for me sitting in Cambridge, Massachusetts right now to be speaking to hundreds of people throughout the world, that has come about because of a set of inventions that made communication smaller, faster, and cheaper. It's very common to say that the iPhone or the smartphone that we carry in our pockets or in our purses today has the computing power of some of the earliest computers. So smaller, faster, and cheaper, that is the model of technological progress. And it's been articulated into business policy and business dogma. My late colleague, Clayton Christensen of Harvard Business School, talked about disruptive innovation, embraced the idea, as many technologists have. And it's described in technologically determinist terms. It's a process in which a product or service enters the bottom of the market. It's simple and it's available and accessible. It's less expensive and more available to people who don't have much money. And then it moves up the market, eventually displacing established competitors. So there is a model of improvement, of progress, and of equality, because something that previously was not available to people at the lower end of the market now has displaced things at the upper end. But you will recognize there the linear model now embraced as a matter of business and innovation strategy even. But people who've been looking at technology policy know that, in fact, the situation is far more complicated, and European scholars, even at the turn of the century, discussed how innovation actually conforms to a different model, sufficiently different that we should refer to it as mode 2 of science and technology, or technoscience. In this mode 2, we recognize that it's not pure science that leads to applications, that leads eventually to innovation and diffusion, but that knowledge is produced already in context of application. And in some sense, it's therefore even appropriate to say that all science, to some extent, is applied science. That science is moreover transdisciplinary. It integrates from many fields. It's generated not only in universities, but also in research centers, consultancies, think tanks, institutes, and in business. Scientists have motivations. They're motivated by the societal implications of their work. The ivory tower is widely recognized as not being the place where the best science is being done. And publics are aware, moreover, that science and technology affect their interests, values, and lives, and therefore science has become far more political than it once used to be. So if mode 2 is the real way that science happens, then we can ask about progress. If progress does not happen by the linear model, how does technology progress? And here I think it's important for all of us to become a little bit literate about the ways in which people who study technology and society have been describing how technology moves forward. So technological determinism assumed that technology was a self-starter, that it was autonomous, that it moved according to its own logic, and that logic produced progress. Later theorists of science and technology have talked about the fact that we construct our technological systems. They are socially constructed, hence they meet social needs, and user demands are important in driving technology. Another widely known framework for discussing technological progress is actor network theory. Actor network theory emphasizes the fact that technological systems are heterogeneous and they have components that are social as well as material and epistemic and abstract in some sense. And changes, therefore, can happen in different nodes of the system. And last but not least, we have come to recognize that technologies are political, that they have politics, as the political scientist Langdon Winner famously said. So one can compare these theories, and here is a little chart that suggests that technological innovation can be thought to occur at different points in this pipeline, not just at the starting end, but at different nodes and at different moments. One can lay these technological systemic frameworks of explanation side by side, and look at their different origin stories, look at the actors who are different from one another in these different frameworks. And then one can ask, how is it that change happens? Now, that last row is probably the most important if we're thinking about policy and if we're thinking about inclusive innovation, because the question of how and where change happens is closely tied with questions of who benefits in society and who is included in the fruits of our innovation. So let me just leave that as a point, a background to come back to and illustrate it with an example that is in the area of drug discovery, which everybody's thinking about now. One can take antibiotics, for instance, and run them through these frameworks and see how elements of the framework are available and could account for pieces of the discovery system. So the linear technological determinist idea suggests that knowledge advances, and so do improvements in life. And one can look at the history of drug development and see how older diagnostic theories that stressed supernatural causes gave way to germ theory, and then Alexander Fleming discovered penicillin, life expectancy eventually was raised. The social construction of technological systems model posits a more dialogic development idea and suggests that knowledge became technology and advanced through our uses. So antibiotics were put to use in wars, pharmaceutical companies leapt on them, and eventually public health authorities started adopting them as well. Actor network is a more systemic system, and it stresses the hybrid environments in which drug development has taken hold and developed. So capitalism and corporate control of science and intellectual property is thought to be one of the drivers of innovation in the actor network theoretical system. And then last but not least, there are political and policy elements in the framework of innovation, for instance, intellectual property and global pharmaceutical companies. And they have led not only to solutions, but to new struggles over such issues as essential drugs and their availability to the world at large. So all of these accounts cover a part of the system of innovation, but not all of it. And we can see immediately if we ask, well, what questions are not included in these theoretical accounts, that they don't seem to have a place for the context of innovation. So what about these larger historical shifts in the background against which innovation happens and technologies emerge? How do we account for phenomena like decolonization and globalization? How do we account for ideological changes such as, sorry, this always happens, such as neoliberalism or the turn toward greener technologies, or the shocks and surprises of our era that include most recently the COVID pandemic? What about conflicts and controversies that have an effect on our understanding of technologies and who is receiving the benefits and who is not? And last but not least, what about questions of responsibility? And that, I think, is the place where this conference and OECD's new directions will be aiming to make the most advances. So who wins and who loses, who is harmed? These kinds of questions are notably absent from many of the technological theories of innovation that we see around us. So let me introduce one other idea that is a bit more complex, but that attempts to sweep in more of this contextual side of innovation. And this is the idea of co-production in STS that suggests we don't just have innovations in a vacuum. We actually want to make certain kinds of worlds that we want to live in, and innovation begins and has its roots in those very worlds. Now, this is a complicated but also a promising idea because it suggests that we can bring entire worlds, more inclusive worlds, if that's what we want, into being through our innovation policies. This kind of co-productionist analysis says that we should be looking at several different points in the process of technological innovation and development. We should be looking at those points of emergence and controversy. We should be looking, important for OECD, at standardization itself as a point of intervention, and at the cultures and practices of knowledge making, and that co-production occurs, last but not least, through very specific mechanisms that we can try to influence in different ways. These include the representations of scientific phenomena, the identities of the people that we are trying to include in our processes, our expert languages, and our institutions. Now, all of this suggests that something that was previously thought to be rather dry and apolitical should instead be regarded as very much a place of politics. So innovation, once you've gone away from the linear pipeline model and you're thinking about co-production, suddenly becomes normative because the futures, these worlds we're making, are spaces that are worth fighting for. They're also places where we make collectives, a space for community building, and the very idea of inclusion is, of course, very closely connected with the kinds of communities that we expect to serve through our technological developments. Making tractable, it's not enough just to have an innovation. We need to make it graspable in some sense, and we need to develop these new modalities of calculation and measurement. And finally, we have to make sure that these developments are in some sense accountable. So let me move to a specific example that is much on people's minds right now and suggest how inclusiveness can be built into the innovation process. So back in 2006, I mean, this is a little bit drawing on my personal experience, Germany launched its so-called Excellence Initiative. And I was involved in the first round of that review process and visited a major university system where people fell upon me immediately to make sure that I would argue for the inclusion of women in the discovery process. The women at this university felt strongly that Germany needed to do more to include women in discovery. And I said, what about other forms of diversity? And at first, my interlocutors didn't even understand what I meant. I meant, of course, the large Turkish population in part that is in Germany. And people assured me that this was not an important thing because that subpopulation was very exclusionary, and they contracted marriages and relationships that kept them out of the social system, so that it was not up to the university in some sense to think about including that minority. Why am I talking about this? Because today, of course, everybody knows that one of the major vaccines, one of the first to be rolled out, in fact, the one developed in the company BioNTech that went into partnership with Pfizer, was developed by this Turkish couple, Şahin and Türeci, who have caused not only a revolution, but a revolution in inclusiveness suddenly. So this is a very recent phenomenon that the city in which BioNTech has its ground, Mainz, has been an indebted city for a very long time. And then all of a sudden, it has now become debt-free because of the benefits that the Şahin Türeci innovations have brought into that city. So here is a model of inclusive innovation that nobody could have predicted a while back. And as I say, in 2006, the idea of how to include that population more centrally into the innovation system was not even in the minds of people who were responding to the Excellence Initiative. So how can we take these examples, these stories that are good stories, and think about globalizing them to some extent? Vaccine innovation has proceeded incredibly rapidly when it comes to the coronavirus vaccines. But here is a sobering assessment from Nature magazine back in December of 2020, a year ago, that vaccine science would not have produced such fast results without the funding. And that article mentions the fact that there's a huge difference between Ebola and COVID-19, because Ebola was located and stayed contained within a relatively poor part of the world. Ebola vaccines, this Nature article says, accordingly took longer to develop. So if we're talking about globalizing inclusion, there are clearly a set of different challenges ahead. So into this mix, we can put OECD. I myself became acquainted with OECD in the course of my first project, but I don't think that that is typical for people doing science and technology policy. Here is a relatively recent article from The Economist, simply titled, "What is OECD?" And it's still the case that the first words that one hears of in connection with OECD is the Club of Mostly Rich Countries. It used to be simply the Club of Rich Countries, but now it's the Club of Mostly Rich Countries. But nevertheless, OECD's 38 member countries still do not include the two countries with approximately a third of the world's population, China or India. So it is a very particular geographic space from which OECD sets out to include people into the benefits of innovation, even though many of the innovations, of course, are beginning within the OECD countries themselves. So how can we imagine OECD going forward? And I think that we have to take the idea of harmonization, which has been so important to the work of OECD, and think of it laid back against this re-theorization of technology and innovation that I've been discussing with you. So we recognize now that technological innovation does not follow a singular trajectory, but rather that it gives us a choice of competing futures, and we're in a position to say something about the particular futures that we want. Nation states in this kind of global federation model of innovation can be thought of as political experiment stations, and they have different styles. American formalism is not the same as British muddling through. So in that context, I think that the new directions have to begin with a set of questions that transform the older questions of science and technology policy into new variants, if you will. So not what is the expert consensus that we can take as a foundation for policy, but what are the assumptions underlying that consensus? Not how good is the knowledge that we can use, but what knowledge was included and what knowledge was excluded. Not how knowledgeable are the publics we seek to serve, but whose questions were left in the debate and whose questions were left out. Not what are the costs and the benefits of a particular innovation trajectory, but who loses and who wins. And not what is the right standard, but in what context will the standard be fitting, who will be served by those standards. So I think that any new way forward for an organization that is international, that is poised to make a difference in science and technology policy, has to take those kinds of questions that it has been considering and rethink them in the context of the world as we know it, especially towards, we hope, the tail end of this pandemic. And with that, let me thank you and hand it back to Alessandra.
Thank you very much, Sheila, for this very interesting conversation and talk you gave. So thank you for reminding us that innovation is not a linear process. That's what we are teaching and preaching here at OECD. And we actually work on what we call co-creation, that you called co-production. So I think the issue of engaging all actors in society to develop and co-imagining the future is really something we really feel strongly about. But for us, the OECD, it's a bit difficult. I mean, we engage with different countries before the 38 OECD countries, of course. We also engage with China, India, and other partners. We engage with the policymakers, with the business and trade unions, but it's harder for us to look at or engage broadly society. And in particular, we heard about in the previous panel, the role that the young generation need to play in co-imagining the future and also co-designing technology development. So we have just 2 minutes left. I was wondering if you can bring to the table some interesting experiment on how to engage younger generations in this political process you were talking about.
Thank you for that question. I think that the way you put it may not be, or may have a rather obvious answer, because it's clear that the younger generation are involving themselves already. I mean, I don't think we've seen so many youth movements as we're seeing in the last few decades. And of course, Greta Thunberg's face is known all over the world now, and Fridays for Future has taken off as itself a worldwide movement. But I think that the question in part is to be more reflective about the work that more technical bodies are doing. I mean, it's still the case that the great swath of technology policy remains pretty hidden from most people. We don't teach about it. Most of our engineering schools are not teaching about the context of innovation. And, then these people that we're training in STEM fields eventually become the policymakers and eventually come to work in the scientific and technical expert advisory committees. So I think there's a gap in perception between the younger generation and the people who become professionalized and eventually move on to the top of the managerial positions. I mean, I think that what's needed is a sort of constant re-fertilization, if you will, of the entirety of the ecosystem with the energies that we already see among the younger people. And moreover, I think that although we're talking about age as one of the, we're presuming that somehow the young are not engaged, and I'm suggesting that the young are engaged. But the North-South differences, the economic area differences, I think remain more fundamental to the problem of inclusion and exclusion. And this is true inside of countries and outside of countries. So I think that the experiments we need to look at are ones that are perhaps not so widely visible, places that are happening in efforts that are happening inside cities rather than at the level of nation states to engage people. I'll just end with one thing I heard at a meeting earlier this year, that the locations that you need to go to engage different populations may be very different. So in this case, an African-American person was talking about the fact that the hairdressing salon may be the best place to communicate with somebody and not an official regulatory hearing to which this person may never come. They may never read the kinds of announcements that go out. So to get public engagement, one has to go where the public is and where the public is prepared to listen, and not assume that just if you open the door, it will be a party to which the public will come.
Thank you. Thank you very much. Sheila, we could go on, but we need to close because we have the next session starting. So thank you so much for being here with us. And we hope to continue the conversation with you as we continue the work. So we will stop here, but stay tuned because we have the next panel 1, starting at 2:20. So on building inclusivity upstream, engaging diverse actors in the development of emerging technology. Thank you again, Sheila.
Thank you, Alessandra. Pleasure to be here.
Bye.